So let's talk about legacy code. And, I think when I was in graduate school, when I thought about legacy code, I thought about, some poor schmo sitting in a basement with no windows and trying to figure out COBOL or Fortran or something like that. But legacy code is actually a good deal more glamorous than that. And I think part of the unexpected surprise is, although by definition, legacy code is code that has been around for a while, there's a lot of things that apply to Agile development when you're creating new code that can also be helpful in understanding and approaching and then adding value to legacy code. So let's start by accepting that legacy code is actually really valuable. Way back when we talked about the origins of software engineering and people who have studied in large software projects where the money goes, that 60% of the overall cost of software over its life cycle has to do with maintenance. And most of that, 60% of the maintenance, is not bug fixes, but it's rather adding enhancements, adding features and functionality to the code. Robert Glass has a great sort of little compendium of the facts and fallacies of software engineering. And one of them says old hardware becomes obsolete, so people discard it and replace it with new hardware. Old software goes into production every night. And that's good because that means that the same amount of effort is being amortized over a longer time, right? It's always sort of deceptively appealing to say, oh, that software's so old, let's just throw it away and start over. As we'll see, that is almost never the right thing to do. So in some sense, having the skill of knowing how to work well with legacy code is maybe more important. Certainly, it is at least as important as the skill of writing brand new or what's often called greenfield code. And by the way, if you do go into industry and you take a position as a software engineer, it is almost a done deal that your first assignment is not going to be, hey, we need this new app and there's 0 lines of code written. Why don't you go do that, right? It's going to be, we have this existing app and we need people to help add value to it in various ways. So, in the sense that that's not your code, you didn't write it, but you still have to sort of understand it well enough to add value. A lot of those skills are really the skills of approaching a legacy code base. So what makes it legacy to begin with? What makes something legacy code as opposed to not legacy code? The sort of first important thing is that it's actually still doing something useful, right? It's meeting some customer's need, and if the software were taken away, that need would not be fulfilled anymore. In addition to that, maybe it's legacy because you didn't write it, and it's not very well documented. So it's going to be a challenge to figure out how to add value. Or maybe you did write it, but you wrote it a long time ago and you didn't write very good documentation. So now you're coming back to your own code and trying to remember, what was I thinking when I wrote that method? Why is this class organized the way it is? But I think kind of my favorite definition is code that lacks good tests regardless of who wrote it. This book, Working Effectively with Legacy Code, is, I think, the best book I've seen on this topic. It's extremely practical, and a lot of the advice that we've distilled in some way or other is inspired by or is adapted from this book by Michael Feathers. But the reason that legacy code can be defined as lacking good tests is twofold. First of all, as with any kind of code, whether it's legacy or greenfield, not having tests makes it really, really scary to modify because you won't necessarily be sure that you didn't break something. But the second reason is that, as we've seen, especially if you consider both the lower level tests like unit and module tests with RSpec, but also the higher level tests like Cucumber scenarios, tests are a form of documentation. At the Cucumber level, the tests can tell you what entire workflows in the app are supposed to do. At the unit level or the module level in RSpec tests, those tests can actually tell you how individual pieces of the code are supposed to behave under different circumstances. So tests are both a form of documentation and a guardrail against doing things that might break the app. And in that regard, any code base that doesn't have good tests, for all practical purposes, you treat it as if it were legacy. So when it comes time to add value or to modify legacy code, broadly speaking, there's 2 ways you can look at that problem. The first one is what I call edit and pray. You edit some things, you think you understood what you were doing, you think you probably didn't break anything, and you sort of, hope for the best. The other one, which obviously I espouse, is cover and modify. And by cover, here I'm referring to test coverage. Good test coverage is like a safety blanket because that is one of your safeguards against knowing whether in the process of modifying the code, did you break something somewhere else? So how can some of the techniques that are used in Agile development of new code also potentially help when you're approaching legacy code. There's a few ways that we can help, but one of them is this idea of determining what the change points are. A lot of things that we do with design patterns and evolving code to match design patterns in Agile has to do with separating out things that change from things that stay the same. And to do that, you have to identify what are the things that could change? What are the change points in the code? Part of exploring legacy code is determining the same thing, because when you're asked to make a change, one of the things you'll have to do is figure out where in the code are you going to have to insert a new seam where you can put your behavior, or is it something that just sort of fits inside a function? So the ability to kind of look at an ensemble of code and ask, where are the seams in this code? Where are the divisions of responsibility? Is also valuable when you're looking at a legacy code base. You will also find that in the process of modifying legacy code, you will almost certainly end up doing some refactoring. Refactoring just refers to changing something about the structure of the code without changing its behavior. And most changes that you'll need to make, unless they are really, really trivial and localized, will probably require some of this refactoring. So when you're refactoring code, the sort of two things you ask about it are, is it already well tested? Like, does it have good test coverage? Can you understand what it's supposed to do? And how testable is it? Even if it doesn't have good test coverage, how easy is it to create new tests for it? Meaning, is it sufficiently decoupled from the other code around it that the thing you want to test can be isolated using doubles and the other strategies that we've seen? So if it's well tested, you're in a good place. You just have to figure out where the change points are. And as you start to make your changes, the existing test coverage will tell you if you've broken something. If it's not very well tested, but it is testable, in other words, the structure of the code lends itself to writing good tests, then you already know how to do BDD and TDD. You can improve test coverage around the parts of the code that you're going to have to change. And now you have your safety blanket. If neither one of those things is true, you may have to start with some careful refactoring to arrange the code in such a way that it becomes more testable. And that's what we're going to focus on in sort of the next few parts of dealing with legacy code. What are the different kinds of refactorings, and when would you apply them? How do you know when they're necessary? And what are the benefits of doing it from the point of view of creating code that is more testable and therefore more maintainable? How can Agile help with all this? We can add tests to improve our test coverage. We know different ways of measuring test coverage. Once we have good test coverage, now we can start to make our changes because we have the test serving as the ground truth of what the app is supposed to behave like. And we can refactor further to leave the code base better than we found it. Almost every refactoring that you are going to do in order to be able to safely modify a piece of code, you'll find that it usually has the effect of leaving the code in a little better shape. And if you think of Agile as it's all about embracing change, this is like embracing change on long time scales, right? Over long time scales, you will have to make changes to the code structure in order to accommodate new features that you didn't foresee when the code was first created. I don't know if anybody knows the origin of this quote, try to leave this world a little better than you found it. This is Lord Robert Baden-Powell, who's actually the founder of the Boy Scouts. Try to leave the world a little bit better than you found it. And I think that includes code. So that's where we're going.